This is lesson lucky number 13. It's on amines and amides. So far we've talked about functional groups that contain oxygen atoms for the most part. And those include alcohols, ethers, aldehydes, ketones, carboxylic acids, and esters. Right? Whereas amines and amides are nitrogen-containing functional groups. Amines are simple. You just have your nitrogen, which can have up to 3 bonds. And anywhere from 1 to 3 of those bonds can be to carbon chains. So if it's only 1 carbon chain, then the other 2 would be hydrogens. If it's 2 carbon chains, then 1 of those is a hydrogen, or up to 3 carbon chains. Right? Whereas an amide, right, we just change the N to a D, right, for amide. One of the carbon chains that is attached to the nitrogen, the first carbon has a double bonded oxygen to it, right? That's the difference from an amine. Right? And I like to think of amides being similar to esters in that when we have an ester, we also have a double bonded oxygen, but then we have a single bonded oxygen and then another carbon chain on this side. Right? And what we've done in order to change an ester to an amide, right, is we replace the oxygen here in the ester with the nitrogen here in the amide. Otherwise, the structure is pretty similar. So the question is now, how do we go about naming these? So we already know that the different functional groups have different suffixes. We find the longest chain that includes the functional group, and then we give the functional group the lowest number, and then that main chain has a certain suffix. Well, the suffixes are easy for amines and amides because the suffix is just amine for amines and amides for amides. So if we look at a quick example, right? If I number 1, 2, 3, 4, right? That would be a butane chain. So we can start with butan. And then if I put an amine, that would be a nitrogen. And we'll keep it simple now by only putting 1 carbon chain on. So we'll put the other 2 bonds to hydrogen, right? Instead of putting an E to make butane, we're gonna instead put amine at the end, because it's an amine. So it's butanamine. And this nitrogen could technically be put on the first carbon or the second carbon of the carbon chain, right? So we have to say that it's on the first carbon, so we'll call it a 1-butanamine, as opposed to a 2-butanamine if it was the nitrogen was coming off the second carbon. Okay? And that's it. It's relatively simple, right? Once we've done that, if we want, we could put branches on it. So I could put like a 2-methyl. If I put a methyl group there, it'd be 2-methyl 1-butanamine. Okay? And it's important to realize that when we're naming amines, that only carbons get numbered, right? So we start numbering here with number 1. The nitrogen doesn't actually get a number, right? So then the question is, what do we do if we add other carbon chains to our nitrogen, right? So instead of the hydrogen, I could put a methyl group there, and then maybe an ethyl group there. So that has 1 carbon, and then it has 2 carbons, right? So in this case, what we refer to is with amines is whether they're primary, secondary, or tertiary, which just means first, second, and third, or 1, 2, or 3. So a nitrogen which only has 1 carbon chain on it would be a primary amine. And a nitrogen which has 2 carbon chains attached to it would be a secondary amine. And then one that has all 3 bonding positions occupied by carbon chains is a tertiary amine. So in this case, we have a tertiary amine. It has all 3 bonding positions occupied by carbon chains. So in that case, you always look for the longest chain, which includes the amine. So in this case, that would be a 4-carbon chain that includes the amine. This would only be a 1-carbon chain attached to the nitrogen. This would only be a 2-carbon chain attached to the nitrogen. So once we've found that longest chain, right, it becomes our main chain. So our main chain doesn't change here. It's still a 1-butanamine. Right? But now we have to figure out a way to name these other carbon chains which are attached to the nitrogen. And because the nitrogen doesn't get a number, right, we can't call it one methyl, one ethyl, because the nitrogen isn't position 1. This carbon is position 1, right? And it's pretty easy to deal with that because we don't actually have to give a number to say where things are attached. If we have our 1-butanamine, right, we could actually just say, alphabetically speaking, E for ethyl comes before M for methyl. We could just say N, ethyl, N methyl, 1-butanamine. So we're saying that the methyl and the ethyl groups are attached to the N as opposed to carbon 1, 2, 3, or 4, right? And it works exactly the same way as if you were using numbers, but if things are attached to the nitrogen, then you just write N instead of the number. Right? So that's relatively easy, right? And then other rules still apply, like you would list them alphabetically, E before M, right? If you have 2 methyl groups, then you could say NN dimethyl, right? The same way we would do if we had multiple methyl groups on a carbon chain. So that's for amines. Right? So how do we do amides? Well, it's the same idea, right? Except we're going to do it with the double bonded oxygen. Right? So this time, the main chain is going to be the one that contains the double bonded oxygen. So if I were to put an N like this, and then I have some long 1, 2, 3, 4, 5 carbon chain there, and then maybe a 1 carbon chain there, and then I'll just put 2 carbons there, right? So this would be carbon 1, carbon 2, carbon 3. In this case, it doesn't actually matter that this is 5 carbons long, right? Because none of these carbons contain the double bonded oxygen, right? It's the carbon that contains both the oxygen and the nitrogen, which becomes carbon 1 of the main chain, right? So this is automatically the main chain because it's the chain that contains the double bonded oxygen and the nitrogen, right? So that becomes our amide chain. So this is technically the amide functional group. It has to be the carbon with both the oxygen and nitrogen on it. So in that case, since we have a 3 carbon chain, that would be prop, N, right? And then instead of finishing it off with an E to make propane, we're going to finish it off with amide. So it's propanamide, right? And in this case, because the nitrogen is always going to be attached to carbon 1 with the double bonded oxygen, right? We don't actually have to say that it's 1 propanamide because it'll always be 1. The amide carbon will always be number 1, right? Then again, we have to say, well, what's on the nitrogen? Well, we have a methyl and a propyl, and M comes before P. So we'll have N methyl. Oh, sorry, not propyl. 5-pentyl, right? So N methyl, N pentyl, propanamide. Right? And that's how we name amines and amides.